into the cloud. Okay, there we go. Now we're back.
Okay, cool.
And we're out pizza now too.
Yeah.
You did it on purpose. It was good.
You want to head to the slide?
Okay.
Okay, so why do you want AREDN? Well, what do you actually use it for? So you can do things. You can post local websites, information about the local area. Email. You can do WinLink over AREDN. So WinLink can go over TCP. You can get it not over the radio or over the radio.
How much is it?
AREDN. Well, the firmware is free. You can source.
But the system.
I'll talk about that in 2 slides. I mean, and it's just a computer, usually most of these services on a Raspberry Pi or a server on top of whatever.
So you don't couple Raspberry Pi with the AREDN?
Yeah, it's just network.
That's awesome.
The only restriction is
No encryption?
it's over amateur radio.
Oh, AREDN is based on amateur radio,
Yeah.
so you can
So you're doing IPv4 networking over amateur radio at high speeds because it's 5 gigahertz wide, 10 megahertz channels.
Wi-Fi spectrum.
Yeah, Wi-Fi basically.
So that's all the credential basically you can say that because it's not encrypted, right?
Don't log into anything.
I mean, you literally use a call sign as the ID.
Oh, your ID is
It's
called.
like a MAC address.
Oh,
Interesting.
Kind of.
The things do have their own MAC address. It's not like AX25 where the call sign is your MAC address. But you usually in the DNS things.
cool.
But yeah, so you can host websites as long as it's not encrypted. It might be useful for having information about the club, pictures, frequency data, and stuff. Files you can download for the internet goes out, it's off power. You can access it locally over the radio. Yeah, email WinLink. So you can usually do WinLink over the internet as well as just over the radio. WinLink's basically radio email. There are some people who have been doing WinLink over TCP, but set the local remote message station that you're connecting to instead of out somewhere on the public internet. It's somewhere on AREDN locally, so a couple hops away, over RF somewhere. You can do cameras. So we have a lot of cameras around the county on mountaintops that you can view over the mesh, or we also host a website on the mesh that aggregates them all together. It takes a screenshot every 5 minutes and updates it, which is also mirrored into the public internet. So if you want to see that, I can show you where to find it. Chat applications, maybe you want to have text chat instead of radio chat. You can post IRC, it's encrypted. Someone made a thing called mesh chat specifically for chatting over AREDN. It's more amateur radio focused. IRC is they kind of just use the internet relay chat stuff for doing it. Matrix chat, similarly, you can set it up to be unencrypted and do chat and pictures and file sharing. As long as you keep the file size small, it works pretty well, even over multi-hop lanes. File sharing, keep your size a couple hundred K meg will be fine. Just don't expect the mesh to be happy with really big files. VoIP. So some people have experimented with doing IP to IP direct calls with those Cisco VoIP phones. So basically, like the handshake hotline phones that we use, but connected over the mesh to do IP to IP calls. Works, I think, pretty well. I've seen some people doing that. I haven't ever tested it myself. And computer-aided dispatch. So in an emergency scenario, if there's a net control, it might be useful for them to have a map. So they host that locally and have a map that has all of their units on it and keeps track of all the stuff in whatever disaster they're responding to. You can have that accessible AREDN, so maybe people can add information to it, upload files, or update their position. Maybe if they have GPS on their phones or whatever other device they have connected to AREDN, that can get forwarded straight into the computer-aided dispatch system, or other people can just view them out to you. So here's a bit about channel planning. It's called the existing channel reuse plan from the AREDN docs. Most of the stuff is on 5 gigahertz, not 2.4. So these are all 5 gigahertz channels. They give examples. So at the tops, you usually want to separate sectors, put a couple sectors based on where you're trying to cover, separate those by channel. I'll talk about it on the next slide. about getting connected with slow, what channels to use and where to point your radios if you're trying to get on the mesh. So yeah, they show you usually want to try to keep channels as far away from as you can from each other, keep different frequencies, separated from the mountaintops.
The question, the slow mesh is this one?
No, this is an example from the AREDN docs. I'll show the slow mesh on this. So yeah, that's just kind of the idea, similar to like cell network planning, try to keep different channels not unused close to each other, right? This especially applies at mountaintops where you have the transceivers back to back with, antennas pointing in opposite directions. So if you wanted to connect, you're in this area, point your radio over there and set it. Right, next slide. So here's our mesh in slow, and a bit about connecting to it. So we have campus here. This is, I believe, the county comp shop connected to TAP or Cuesta, and there's TAS. And then the club sector connected out to someone in Los Osos. So we have a link here to here, point to point RF is here, and there. And then there's a sector here that covers campus and the comp shop. And this is a sector that covers Los Osos and Morro Bay. So if you're in Slow City, point your radios at Cuesta. That's the huge radio site. You can see the big TV tower and a bunch of other towers. As soon as you step off campus, you can see it. On campus, it's a little obscured. The only way you get to it from on campus is from the top of our tower, where we have a big antenna pointing out, and the link is still pretty bad. But as soon as you step off campus down anywhere in the rest of the city, you can get line of sight to Cuesta and line up radio, and from the mesh from there, that will be on channel 173. If you have line of sight to Clark, or if you're in Los Osos and Morro Bay area, you can point at Clark on channel 178. If you're in Atascadero, name the mountain where you want to point at TAS. Up here, so if you're in this area, there's a sector here pointing north on channel 136.
Quick question, are we able to access this through our radio? Like a radio? So we have one.
If we can do 5 gigahertz, I'll talk about that in a second. What you need to access this. And if you know what, you can tunnel in. Right now, you pretty much need to buy a hack to tunnel in, something that can run the AREDN firmware and use their proprietary tunneling. It built it off of some project, how their tunnels work. But I think in the most recent nightly builds, they've added WireGuard support for WireGuard VPN in from the public internet that you can get off this as well. But that's still super experimental, so maybe in a couple months. Yeah, so that's about it. If you need help connecting and slow, I can help you. There's from campus, if you go over by Yakitutu or up the hill, up on the P behind Vista Grande area, you have line of sight out to Clark. So I've made that link before too. That's what the photo of me in the back was. We connected out to Clark. But this link to Cuesta should be better off campus. And then next up is the hardware. What you need to buy, it's all pretty relatively cheap, less than $100. If you need hardware, I can give or lend it to you. The router board from Microtik is a little router. Everyone loves these for AREDN. They don't actually have a radio for doing the long distance links, but for AREDN sites, when you have multiple point to point or multi-point type stuff, they're really helpful. They're really good they're running the AREDN firmware, and they have multiple ports to do a bunch of routing tools. You can set VLANs and do cool things to bridge multiple AREDN devices together to get the actual routing, like routing behavior you're looking for. These nanostations are really good. You can find them cheap on eBay. Look up the Ubiquiti nanostation M5. You want the M5, that's the 5 gigahertz model. You can flash AREDN firmware on there. Point those. They have a couple of direct antennas in the front, with 2 or 4. I think you remember the directional antennas in front of these. Like 2 by. Okay, yeah. 4 antennas. Yeah, these 4 antennas in the front that form an array. And then if anyone who was here for the last meeting, they're MIMO as well. So they have their patch antennas fed both horizontally and vertically polarized, to do directional. Not super directional, but pretty directional in the way you point. Those are cheap and pretty easy to find. And then rockets also fairly cheap and pretty easy to find. Also, you can put arm firmware on them, and then these just have two internet connectors on top, and you just have to find or build them. There's some other hardware on the quite a bit of other supported hardware on the AREDN docks. So basically, whatever you can find, but a lot of it's going to be old, like wireless internet service provider gear. But if you want, the club has some extra rockets and nano stations. If you want to do it home, borrow it for months, or possibly even have it. And we don't have uses for a lot of these. We have a bunch of spares. We don't have spare half, but we have spare everything else.
Well, if you have that, you need to have the other one, right?
No, you don't need to have. You can do all everything without it. It's really useful, especially if you have multiple of these connected to in different directions, or at a mountaintop where you have multiple sectors and you kind of link them together and do other weird routing stuff. It's helpful.
But these you need to be on like top tower or something to get the other one, or how
Anywhere you have line of sight. As long as you can see the tower on the hilltop where the sector is, the higher you go, the easier it is. So if you have,
Those are obstructions.
yeah, if you have a pole or a tripod or something to mount on the roof at your house, that makes it easier. You don't really need a tower. If you're on campus, you need a tower just because of the ridge and the hills over there and stuff. And then if you wanted to tunnel in, if you don't have line of sight or can't mount an antenna on your house or whatever, you can the app, the microchip router board, runs AREDN firmware, and it's probably the best option for being a tunnel client. So you connect that to the internet on one port, and then it acts as the router with the VPN client essentially. So it VPNs you into the network, and then
so how does it connect to the AREDN network?
on the AREDN, you put another one of these apps on the AREDN network, connected to the internet, and the rest of the network run the server there. So people on the internet. So that's the easiest way.
Can we try this? Like, can we do this in one platform?
We do. We have a node on the tower and an app in the shack. I'm not making some of the other stuff around. But that's why I'm participating, because I want more club members to be involved with the AREDN stuff we do. That's. Anyone else has any other questions?
Okay, so thank you.
Yeah, I got one.
Yeah.
So curious, like someone now, but if you want to explain why you need PDP over TTP, or did you explain that?
Why
Why
you
you use camera?
well, if you don't want all the overhead of TCP, if you're trying to build your own thing that does error correction and deals with the frame reassembly, you want that. Or if you're trying to do something low latency, so video calling, voice calling, video streaming, that kind of stuff. You don't want all the overhead that TCP does. That it ensures all your packets get there in order, correct? But like in a voice call, that's not what you want. You don't want to wait for the voice traffic to come in order. You want to just throw away whatever wasn't there and keep moving on and stay live. Live streams use that.
I just found it on
Voice calls use that.
So we can go to chicken.
Or if you're your own TCP. Because what's the
Then the running
your own
like we're running a chat message or something.
it's another layer for protocol, but
I wish people were active on their
it's actually
when I kind of give different ideas to nobody who really at one channel I set up
it's like
on my radio I set up all like other features.
so provides all the
And you can know when not lots of people like nowadays use it. It's just make only by probably and oh shit. Otherwise, yeah. It's there for every
just like IP over you want to do IP over packet radio. TCP is really not. TCP, it guarantees that you have like all your frames in order and correct. But if you get anywhere above like 1 to 3% packet loss, the TCP connection just grinds to a complete halt and is unusable. Whereas UDP, 1 to 3% packet loss, design your program to deal with 1 to 3% packet loss. Right. So if you're trying to do IP over AX25, you probably really don't want to be running TCP over AX. Radio AX25 really wasn't designed. It'll commonly go 10-15% packet loss.
And you want to explain about the mesh map, how you can look at all the nodes and where they're connected and all that.
Mesh map, some people host these. So as I was saying, the OSLR, everybody built a map essentially in memory, so you can take that and actually render it out with the GPS coordinates and post that on the public internet. You end up map SoCal. Go back a couple slides. That's where I pulled this screenshot from. This is from KN6REG's posted version of mesh map. You can just look at KN6PLD mesh map. He is actually we're tunneled. I think it's this half here, this link right here is tunneled into the LA mesh, so you can get into a couple hops around the mesh. There's one in the Bay Area, a couple others. One thing though, those mesh maps look huge. You actually really can't access most of what's on them. You can access maybe like 3 or 4 hops. Like what's really close to you, yes, like we can access any of the nodes on you. You might be able to ping them. Routing anomalies, I don't know, it gets really, really slow when you're trying to go 4 or 5
Multiple hops.
4 hops.
Yeah.
You can go a couple. Basically anything on here should be acceptable to Canvas. But beyond that, there's nothing.
Also, think.